Hello. So let's continue working on the kana stats command. And before I do that, by the way, I do want to fix something that is bothering me. This is complete UTF-8 is a bit more complex than needed. So we can actually change this to just pass the first character in the UTF-8 thing, the UTF-8 byte stream, and we don't really need to distinguish between size too big and size too little. So unrecognized size there, and so we will change this past the only one character, and this should work. Buff 0, 0. Oh, right. Okay. First char. All right. There we go. Good. So I will fix up that h2k command commit. Git rebase I. Oh, that didn't work. Kind of stats. Kind of stats. Deleted by 1. It was deleted. Did I accidentally delete that file? Kind of stats. Oh, I think I committed too much here that I should not have done. Okay, so I will okay, so let's save this somewhere else, h2k.c in temp folder, and I will reset this git rebase dash dash abort. Okay, rebase, oh no, git reset hard. Okay, so right. Now the kana stats command is going to have extra stuff here which we don't really use, and we will go ahead and change so let's fix that. We don't need this here. Kana counts because code point range is in chars.h at this point. Yes, okay. Alright, so let's fix that. Let's amend that. Okay, and then we want to fix this as we were planning. So I will delete everything and read in the temp file we just created, and there we go. Good. So then I will do another fix up and then rebase it in the right place. And now we're done. So I don't think that I made sure that everything builds like every single step of the way. Let me try that. I'm going to make sure every commit is functional, because I remember we changed the flag behavior, and so want to make sure that's still working. Okay, so let's check out H3. All right, H2. Okay, and kana stats. Okay, so for this, I want to do a test-driven development approach. So I'm going to create the test right now, and or at least the boilerplate. So kana stats test. All right, and headers, shared objects. Okay, I think that's all we need to do if we want a new test. So let's, what's the last test we made? H2K test. So let's write this to kana stats test.c. Kana stats test. Okay, and so what we'll do is we'll have these all in. I guess we kind of want separate files for the input. We don't really want to keep them So, so I was thinking that we do need to change something here. So if we look at 2, we added some configurability to the tests. So what we can do now is we could go to see testutil.h, and we can fix that up a little bit so we can actually make this even more sophisticated. So it is struct test config, and we can have that this ignore null bytes as one setting. The other one is char const standard standard in source, standard in file. Okay. Oh no, we want to do this. We will do unsigned standard in from file. Okay. Test. Okay. Edit testutil.c. Okay. So we have that flags thing we don't really need anymore. So the reason I'm changing it from a flags to a struct is because I do plan on adding like a letting you pass in a standard in, like a file name as the source file for standard in. But for now, we're just going to have a flag which says get standard in from a kind of path which we automatically determine based on the test name. Get standard in from file determined from test name. On the other hand, we can just do that anyway, right? We don't need to ask permission exactly. File yeah, but the thing is, we're using standard in as like a as a kind of string. There's like a string that we can use. So here, let's try this. We're gonna make this configurable first. We'll say standard in bytes. So I don't know how we're gonna handle we're just gonna say that it's null terminated for now. So here, config tests, edit testutil.c, test config, static, struct, test config, config. All right. Okay, so we'll do config equals config. I think that's all we need. And so look for flags, config dash use, what did we call it? We call it ignore null bytes. Okay. So, right. Now the other thing we want to do is we want to go and see if config is, let's see, config. Oh, but the thing is, for a test file name, do we really need to put it in the config struct, like as a kind of a something that you don't do directly? Maybe we can just make a special function for setting the standard in. Because if we look at h2k.c, h2k test, we do store in temp file, then we do start test. So basically, we could just make this into a function which is called separately. So the idea is that in connet stats tests, we do want to we basically are interested in using a input file like based on the test name. So okay. So what we can do is we can let's revert the changes to the test because now I don't have any excuse for using a struct. All right. Now what are the changes? Okay. So let's open testutil.h and we'll do we'll call this one config test standard in from file. Okay. I'll just do that. Edit testutil.c config. Okay. So now we want to look for where we determine the standard out or the output file name and expected test input. So we're going to have to make a new test expected content in file. So then we do, let's see, we do start test. So down here, we're also going to have to check if config dash, we call it flags and config test standard in from file. Yeah, let's do, okay, that means we need to figure out the input file name in file name, right? And so we'll do xas printf, and we'll do input file name, and we'll put it in. So we have a directory called expected test out. Where did I go? I jumped around. Okay. Where is that? Expected test out right here. So how did we use that expected test out? See, I'm checking back to how I did it before, because I don't want to change the style or change the way that we've been doing things. So let's say we'll call this input fn, and we so test input /%s dot %s and test source file test name. And I think that we have those. Yes, we do have them. Let's yes. So now let me wrap these lines properly. Okay. So next we can do standard in. Okay. So we want to set input to xf open, I guess. Let's go to hk to test. Do in equals xf open input input fn and r for read only, and then we continue with the test. Right. So now I wonder, do we want to let's put this down at the bottom just for uniformity, and okay, no, it doesn't quite fit. Okay, then we can free input. Okay. Now we want to handle this at the end as well. So we're going to what we'll do is we're going to figure out if the test was complete, the file was completely read from or not. So to do that, we'll do a xf get c, and we give it in. So we go to util.h xf get c. So if that is not equal to -1, then we can say die the production code or the test, let's see, the application code did not consume all of input. Right. And next, so we will do an xf close of in, and say in equals standard in. Okay. Actual fn. Right. xf close out. Okay. That looks good. So transfer file. So all right. So that's pretty simple. So or self-contained. So now let's go to kana stats test, and we'll say let's see. We don't need this, I guess. We'll say something like start test file empty input, right? And then end test the expected content and file, and we'll do a config test. So test config, all right. Struct test config. Oh no, it's not a struct, it's a flag. Int test flags equals config test standard in from file. Okay. Okay, and we don't want to ignore null bytes. Okay. So that means we just need testutil, I suppose. Oh no, but we do want to run this thing. So we'll do kana stats. Edit kana stats. Let's see. And we have, okay, so it's a function. So we'll just do if kana stat. So int exit. Right. If exit is not equal to 0, then we'll do xf printf out exit code d. Well, we don't have to make it conditional. We can just always do it because we're going to put this in a separate file anyway. So it's not going to clutter anything. So we'll do 0, 0. All right. Kind of stats. Great. Now, because this is just one line, I'll just make an exception to the rule. Now we'll do make kana stats test. Okay. Some careless coding errors in here. Test input is okay. Input fn. Oh, now it fits on one line. Great. Okay. Edit. So we want to pass 0 for when we call die. Til.c. Because we don't want it to print standard. We don't want it to print error no automatically. Okay. Empty input. No such file directory. File name. Test input. Okay. So make dir test input. And we'll touch there. Great. So now we can, let's try again. Failure. Test failed. Bug at romaji.c, lines 330. Okay, I guess that's because we didn't initialize romaji. 10 potential mappings. Romaji config for CLI flags that include no kanji numerals. Didn't actually init Romaji. Okay, init Romaji. There we go. Address of Romaji config. Okay. Okay, so there's no file, or no, expected test out into input. Okay. So what do we want our table to look like? So we want to see here. Okay. So we're going to have in the first column a list of all the volley kana possibilities, but we're not going to show it if it did not appear at all. So what we'll do is we'll have columns which say the number of hiragana. So let's see here. Hiragana count. Hiragana and okay. So this says the number of hiragana characters, and next we'll have I guess a space. I don't know. I'm not sure if I like the way this looks because we're kind of being redundant. I guess that's good. Number of hiragana, and then we'll do the same thing again for a number of katakana. I think that's yeah, katakana. Right. Number, and we'll just repeat this here. Okay. And then that is what it looks like. So we'll have at the very bottom, we'll have like total. Right. Okay. And this will be number. Let's see here. Number and percent 0, 0, about 0.124. Okay. I was interrupted for a second there. So we have 0, 1, 2, 3, 4. Okay. I don't like the way this doesn't line up very well. Okay. And we'll do this. Okay. So, right. Now, how large are these numbers going to be able to get? So right now we have 1, 2, 3, 4, 5, 6, 7, 8 digits. So that's like 100,000 of a certain character. That's a lot. Let's just give it 2 more digits. Right. And I'll put some extra space here as well. Okay. Let's center these. It's not really centered. It's hard to center with this number of characters. So should we just remove 1 digit there? Yeah, I guess that's fine. Okay. That could be fixed later, I guess. Let's just make it this, add a digit rather than remove one. Okay. 2 on either side. There. Okay. Good. All right. Okay. Good. But I guess we want to have the numbers right aligned. That looks a little bit more standard. That means we don't want space here, right? Don't want so much space here. We want it on the other side. Okay. So we have, let's say we want 10 digits. So if we use 32-bit numbers, we're going to have up to 2 billion or so. So that is 10 digits. Let's say we support up to 8 digits. Or let's just do 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Okay, then we need a space. And then after that, we don't need any more. 1, 2. Okay, let's have 2 spaces if you include all the digits. Great. So before this, we have 1, 2, 3, 4. Okay. Let's say 1, 2, 3, 4. All right. That looks good. And then we also want the number of the amount that it appears. So this is the amount that appears in this is the percentage that it appears as far as like this all the kana characters, but we also want the percentage that it appears in all characters total. So we'll have like including kanji, the number of characters the percentage of times this character will appear. So zen moji chu no. Okay. Then this is always going to be 25.12345. That's going to be hard coded. We'll make it right justified. Okay. Because we're basically using the rule of thumb that the kana should appear at 25% of all the characters, and the other 75% should be kanji. And this is kind of a rough rule of thumb. Okay, so this is basically what it needs to look like. Okay, so this is the empty file, right? So let's go to kana stats.c, and we will do this. So we don't parse the flags yet, but we will eventually. This is really just boilerplate. So init hash map. Okay. So we will collect potential mappings, destroy hash map. So that's just for collecting the mappings. Let's go down here and actually write this. So we have 1, 2, 3, 4. Let's copy this. So do xf put s standards out, and okay. And that's obviously a hack just to get this test to pass. Okay, out. Okay. Great. That's, let's see why it's not. Okay, exit code. Exit code 0. Okay. Great, that is working now. So let's say, let's just stage these changes so we can diff a little bit more easily. And soon we're gonna have to start getting to work. So let's say we have like, let's put something here like and then we'll say it's one hiragana, and that's 50%, or let's just say that's, oh, we don't have it. We need another digit for 100. Okay, so let's change this in case it's 100%. All right, good. And this is 100. No. And then here we have 25. Okay. But this should be written as expected test out, kana stats test.c.trivial, or let's say 1 char. Okay. Let's edit or find 1 char. Stats test. Find kana stats. Trying to get to the file that I just created. There. Here, empty input should not be have anything in it. There. Okay. So now we go to the test file again. Edit test. Edit kana. What is it called? Kana stats test. And we'll say 1 char. 1 char. Okay. And that's going to fail, obviously, because we're just hard coding everything. Okay. So, input kana stats test. Empty input. Oh, right. This is now no longer correct. Right. Try again. Okay. 1 char. Cannot open test input. 1 char. Oh, I put it in expected test out. Oh, no, that was correct. I didn't input. So we'll go to test input and open up kana stats test. See 1.1 char. And we'll just do this. Okay. Let's try that. Application did not consume all of input. Okay. So what we'll do is we will. So we don't, rather than collect potential mappings for now, let's just do this. We will init hashmap stats with just 32 buckets, I guess. Or what we can do is we can be like, let's just call it int 32 or int count. So we're just going to count this character here. All right. Now, in order to do that, okay, let's just see how it goes. We'll go count equals that, and we will put s. Okay. Okay, then. What we'll do is we will say if count is not equal to if count. If we have a count here, then we're going to print it out, this information. Count xf put s. Oh, but we need to update this this part here. This is not correct. And I guess having this here doesn't make sense, because this is oh, this will end up telling us the number of katakana versus hiragana. So that's kind of helpful, I suppose, to have that number there. So a count, then we'll do xf printf out, and we'll do okay. Okay, count. Then we print out the and xf put s out. Okay. Now, how do we know if count is non-zero? So what we'll do is we'll say let's just do this very simple. So we're just writing the bare minimum amount of code to make the test pass. So we'll do xf get c of in is not equal to -1. We'll say a count plus a count equals 1. There. Okay. Collect potential mappings is not used. Okay. Let's try again. Good, the test pass. But this should actually be 100 here. Yes. Okay. So that's not correct. So we will change this to change this to %d, I suppose, and we'll give it a count or xf printf and out d, and %d should be a count. Okay. All right. This percentage is not correct. So we have to, how are we going to calculate this? So we want to, yeah, actually test-driven development is hard. I have to think a little bit backwards at this point. So this is, this would be, percent 3D, I guess. And it would be a count times 100. Okay, let's try that. 3D dot a count. All right. A count and a count times 100. Okay. All right, that passed. So so good. Now we probably want to do two. We'll do. Okay. Now what? Let's just do two chars. Edit kana stats test. All right. 2 chars, and we'll take this edit test input / kana stats test dot 2 chars, and we'll give it right. And here we'll open expect test out kana stats test dot 2 chars, and then we'll copy this, right, and this will be 2 and 2. Great. Now that's going to fail because this 100% should not be is basically incorrect. Here, make Okay. So the first line is wrong. The second line is wrong. Let's see. Edit kana stats test. Edit kana stats.c. Okay, so let's do plus plus here, and a count divided by equals 3. Okay, that is going to give us the number of kana that we found. Now, now here, let's see how that works. Make J1, right? And so here we have A1. Okay, this number is incorrect, but goke, the total, is correct. That's good. So we'll change this to %d. Okay. Then what else? So we need to go and let's see. Is that all we need to do? Oh, and that 200. This is not correct. Let's try 1%d. Okay. A count. All right, and diff again, and now we have this. Okay, so here what we'll do is we'll say if a count is 1, then we'll say 100. If it's not, we'll give it 0. Right, so that's very hacky, obviously. Good. So we're making some progress now. I think that I will commit this, but obviously not push it because it looks awful. And so you can see the code is starting to come into shape a little bit. We decided what the output's going to look like, and we have kind of a nice, we have like a nice stability factor. We know that this is not going to change, and we have tests to prove it. Now this code is going to change a bit, but it's actually not going to change a huge amount. Like %3d is correct. This %d will eventually be %3d. And this is obviously totally wrong, but at least we kind of have the overall feel of the loop and counting characters. That's pretty good. So let's see here. So what can I do next? What we can do is make sure that we can change this so that it's aligned correctly. So we'll say like we'll do like 100 chars, I guess. Let's try that. Edit test input / kana stats test / 100 chars. Right. Then do is we'll add 5 and we'll multiply that by 20. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Okay. And it's acting a little laggy right now. Oh, I see why, because it's only one line, so it's not allowing me to do that. Okay. So we have, let's open the kana stats test, and we'll do 100 chars. 100 chars. And we'll edit expected test out / kana stats test.c dash dot 100 chars. Okay, and we'll copy this. All right. This is 100, 100. Okay, let's see how that works. Of course, it will not work. here we go. Okay, it's misaligned, obviously. So we'll go to kana stats.c, and we will do %3d, %3d, and delete 2 out of here. Okay, good. That worked. Great. So what else? So we've tested the alignment. So we probably want to allow, let's try having a mix of 2 different characters. So we'll have katakana and or hiragana and hiragana something else. Ro, maybe. Just some other character is fine. And we will do something like, let's see, edit test input slash kana stats test.c dot mix 2 chars. All right. And roll. Right. There we go. And then we're going to go here and expected test out, kana stats test.c, and we call it mix 2 chars. All right, we're going to copy this, paste it in here. And yes, next we'll say that this is 1, this is 1, and the total is 2. And this is going to be, finally, this is going to be kind of interesting. 50, 50. And over there, this is going to be interesting. This is going to be 12.5, right? 1, 2, 3, 4, 12.5. Okay. Good. So this is definitely going to fail. Oh, no, I didn't actually add the test. Kana stats test. Call it mix 2 chars. Okay, let's try that. So let's just run the thing we want to make kana stats test. That's easier and probably faster. Okay. So at this point we have to count a and ro. So we can go to kana stats.c, and we can probably just count the number of bytes of each a certain byte, like that that appears in both of them. So we can do echo a or hex. So, and then we do roll. And you can see that we have 820. So 8.1 and 8.2 are unique to each one. So let's see here. We're going to delete this. Int c equals xf get c, and get in. If c is -1, then break. Otherwise, if c is AD1, then we increase a count. And then if c is 82, then we increase roll count. All right. And I don't think we need to divide by 3 anymore. A count. Okay. Now we're going to copy this. Roll count and roll. All right. Okay. A count. Okay, let's see how that works. It's not going to pass because there's other stuff that has to change. I'm going to do it like, yeah, let's just do that. That's fine. Okay. Let's see. Roll. Expected test out, kana stats test. One char to test out. Oh, okay. So we haven't roll, I guess, one char. Why is that? Do we have 81, 82, A count? It seems to be counting roll even though there's no roll that I can see. If roll count. By the way, let me fix this. I have extra braces that are not needed. Okay, expected test out. Let's just look at the actual test out. Okay, it includes roll, which doesn't make sense. One. Okay. Oh, that's confusing. Why would it include one char? Edit. Roll count should definitely be 0. Let's do hex dump C, and we'll do test input slash kana stats test dot one char. Okay, we have 8182. Wait a second, did I miscalculate this? Oh, has 82 in it as well, and roll only has 8D. So we have to change what we're using to as the distinguishing byte. Let's try this again. Okay, so here we're getting closer. We don't have the right value here for the percentage. So we also don't have the right percentage over here. So what we can do is we can create like a struct for percent. So I don't want to use a floating point. And so we'll have like int numerator and int denominator. Or maybe we don't even have to do it this sophisticated. So what we can do is instead of 100, but we need to support this thing here. This is tricky. So let's do %3D, and then the A count is going to be okay. The percent is going to be 100 times A count divided by A count plus row count. Right, that's the correct formula. Now, if that's 0, it's not going to work. I guess it's going to cause a problem. Okay. I'm trying to adjust the adjust alignment and everything. Okay. That looks better. Okay, so I think that's correct. Let me make this, run this test and see if it looks correct. 50. Okay, so this 50 is correct, but this part is not correct. Okay. So we will go ahead and fix that. This has to be %3D 25. And this is %505D. %05D. So they pad it with zeros. All right, and this is going to be this is going to be basically that percentage divided by 4. So we'll do 25 times a count divided by a count plus row count. And then it's going to be that, but times 10,000 to get all those extra digits back there. Oh, but how many digits do we want? Do we really want that many digits? I guess we can do that many digits. That's fine. It's percent 5D, and then 25, 1, 2, 3, 4, 5 times a count divided by a count plus little count, and then modulo 10,000 or 100,000 to get rid of the digits above to get rid of the digits above the decimal. Right? Let's try that. Okay, I think I'm going to try and wrap this up soon, but let's get at least this working. Okay, is working good. That's great. So we're going to do row count next. Now that's going to be similar to this, and here. Row count. Okay. All right, let's try that. Oopsie. Okay, row kana stats test mix two chars. Okay, now it's not in the correct order. Is that the problem? It's not the so row oh, here we go. Speedo. Okay. And the total. So the total is that we have to add up a count and row count. A count plus row count. 3D. Oh, this percent 3D is not correct. It's not a percentage, is it? So we're gonna have to fix that eventually. Okay, good. All the tests pass. So we made some pretty good progress. I'm going to amend this. Actually, let me fix the alignment here. Count. There we go. Okay. So the percent 3D is not even needed, so I think I might want to get rid of that, because it's kind of like giving me a false sense of like completeness. Because I don't think it ever goes above 1 digit at the moment. Make kana stats test. Okay, I've broken it. 100. Oh, because we do have 100 there. That's why. Okay, that's fine. So now we can make all the tests pass. All right, so amend, and so this is looking kind of interesting. We do need to simplify this. There's a lot of repeated code here, and we don't really want that. So what I'll do is cut it off for now. We'll stop the video for now, but next time we're just going to finish hashing this out. I'm not really sure what next step I want to take is yet. If I started coding, I would figure it out, but right now I don't know off the top of my head. We could add support for more characters, but the thing is, that's just going to make this hack more and more ugly without really accomplishing much. What we could do is add support for like the combined nomaji, like kyo. Like this is 2 characters, but it's treated as 1. Let's paste this into a web browser window here. New. Okay, so for example, this, we need to support this eventually. There we go. We need to support this two kind of characters that are treated as one, or treated as a single input sequence. And anyway, so we'll be working on something like that next. And until then, this has been a kind of a test-driven development session, and I'll probably want to continue doing this for the entire sequence of events of implementing this. So until we meet again, thank you for watching.